checking whether you can hear me.
Hello, yes. We can hear
Okay,
you.
that's good.
Yeah.
There has been some problems with my headings. How about the last time? Do you have any questions so far?
Yeah, but I think I would like to ask them after the theory part in the end of the lesson.
Okay. Today the lecturing part is quite a short one, so you have plenty of time to do your data analysis and ask specific questions concerning about your cases. I will end the lectures 9:45 at the latest, probably a little bit earlier because there is plenty of meetings today and I am so sorry, but I need some food sometimes. So let's start. I hopefully find my lectures somewhere. Nope. So today we talk about dispersion. Last time we have cases for location, and hopefully you understood that some of them are used in for nominal cases, nominal variables, some for scale variables, some of them maybe you have a little bit sense what kind of variable you have. So like the age, it can be ordinal, it can be scale, depending the situation, what kind of information you want to give. Location was very easy to explain because there is a graphical way of showing what it actually means. Dispersion is not so easy. There are, as you see, 3 cases mentioned here. Brains is easiest because it's just the difference between maximum and minimum value. So actual meaning is the same as for functions. What is range? What kind of values you can give here? It just tells you what kind of values you have. In the quartile range, usually used IQR with uppercase letters or QR in small case letters is difference between the upper and lower quartile. And if we have this box case, it would be from here to here. So it tells you how much is, in this case, the length, if it's drawn, otherwise what is the height of the box. And quartile deviation is half of it, and so it would be here. And if that value is about the same as median, then you know that it is symmetrical. This box part, it doesn't tell you anything about these and these. It just tells that where most of the values are, where it is a symmetrical case. These are also very easy to solve, no problem. The problem here is that if you include more data or you exclude the data, these values may change. So they are not unique. The same is of course for the range. If you add their values and one of them is new minimum or new maximum, it also changes. But both of them are good ones because they are easy and they actually tell you quite much. Of course, not as much as you would like to have. How many of you can just put your hands on or something like that is familiar with the standard deviation? Have you ever heard about that? Or is it totally new thing? Okay, at least for some. Just think about that you have a column of data. You already know how to get the mean value of it. So basically, when you know the mean, you can solve the difference between the actual value at any row minus the mean, and you get the differences. These differences can be positive or negative. So if you just want to get what is the sum of these differences, it can actually show you the value 0, although in the individual ones are something else but 0. So actually you may lose a lot of information. So for that reason, you need the absolute value, so it tells you that there actually is some differences. If you are doing this with paper and pen, the absolute values basically are not a problem at all. But if you use programs, it is not so easy. Also, the problem here is that the more data you have, the more this sum is, despite whether these are very small or not. So for the data of 10 observations and for the data of 1000 observation, there is a big difference in the sum. So for comparing, it is not very good one. So that's why you should divide this one with the number of observation. So it gives you a little bit more value to use it for it's morning, I lose the words, comparing a different kind of data of the same case. And this kind of sum is basically a good one, but because these absolute values are not so easy, probably it was just at the beginning of the calculators and so on, where this square root one was the easy one to get the information. If you square this difference, the sign is affected, so you will get the actual difference. It is just squared one. And if this formula is given in this form, it is talk about it is a variance. And if square root of it is taken, it is called as standard deviation. So if you have the table of normal distribution, the mean should be 0 and the standard deviation equals to 1, meaning that also variance is equal to 1. Variance is the one what is mainly used because it is part of the hypothesis tests, but we are talking next week. But if you think about with the units, it has no sense, because if your is about weight, it could be squared kilos or something like that. So for reports and so on, standard deviation is used because when you can actually keep it in the same unit as the original variable. The biggest difference here between these two formulas is what is the number of observation used. So basically this is formula when you have the whole population, and this is the formula you use when you have only a sample. The smaller sample, the bigger mistake, bigger error here in your calculations. From this point forward, when you have a Greek letter, it refers that it's for the population. The normal letter with in the same way used refers to the sample. And if you check your data and you get the values for standard deviation and so on, it will always give you the values with this one. It always uses because they are all samples. Of course, the good thing here is that if the n is closer to infinite, these are almost the same. So the more data, basically these are actually same. But you have to remember that you are basically always getting values for samples, not for the population. Now you may think, what is the difference with the sample and with the population? Sample formulas are used if the number of observations is less than 30. If you do not have the actual mean and standard deviation, and mainly the standard deviation. So this separates the things in the hypothesis tests. We talk about this one also later. But at this point, just start to remember that if a formula is with the Greek letter, it should be the value of the population, the value of what is known for sure. And if it's just a normal letter, it would be the value which is given to you by your own data. So the standard deviation is just the square root of it, and as you see, here is the actual formula. For this course, remembering what the formulas are, it is not so important because we use the SPS all the time. And probably you noticed from Peppy that exam is not recommended for this course. Just because some of the formulas here are quite awful, but at least the numerical formulas are so bad that the numerical part of this course is not worth of doing it with normal exam. One nice dispersion thing is the coefficient of variation. So you have your standard deviation divided by mean. This can be solved if your variables are in ratio scale, so they are numerical by nature. And it is used to give the idea when you are comparing values which have a different unit. So like in this example, there is salaries in dollars and in pounds, and with this formula you can get the value, how they are deviated. So because this one is the larger one, the deviation is larger in Great Britain as in USA for this data and for these salaries. And like everything in statistics, it is always about the data you have. You cannot say anything for sure, but for this case it seems to be. Here is some kind of a summarized part. So what kind of location measurement you can use, and what would be measure of a spread dispersion at that case. And here is also about the outliers. So every time check them, you are one responsible for your data, meaning that you make all the decisions. So for this NBA player, it's your decision. Do you exclude it? Do you include it? Do you include it with big value, but not the actual value? So like upper quartile value or something like that. If it's not impossible value or mistake which you cannot correct, don't automatically remove it. Make the decision, explain it to yourself and to the others. Why did you exclude it? And always remember in your report, mention the reason, and if this is used, have some kind of comment that was excluded or replaced with other value or something like that. Otherwise, you may give the reader incorrect idea of your analysis. Factors and responses, these are very important. You have to figure out which case you have, especially when you go to the hypothesis test and so on. So the factor is always the value which you already know. So you have decided that value. The response is the value obtained by measuring. So all the analysis what we do for data is always done for responses, because there are the differences. Factors are decided beforehand, so there is nothing to study. So, for example, here we have a researcher of medical things. There is a drug tested, and as you know, when they're testing the drug, they need to have some sample where this drug is not given to see whether the drug is has any effect or not. And there is also in this case two kind of patients, slightly sick and severely sick, and so on. So the among the states of disease is the block factor, because they have been decided. I take the 20 of these, I take 20 of these. how much drug is given is the treatment factor, and it is also decided beforehand. The only thing what this researcher even can study is how the blood count is acting. So what is happening here? So if you go to the laboratory and you decide that I do this test, for example, with 2 kilos and 4 kilos, 10 times for each, they are factors because you decided them. So basically this was the lecturing part, and now if you have any questions of the basic of statistics, you can ask.
Yeah, I have a couple of questions that is related to the data you have given. So may I share my screen? So
Yes,
my
I just,
connection.
yeah, now it's open for you.
Yeah, should be this one, I guess. So can you see like the data I'm now pressing CT. Can you see that?
Yeah, yes I can.
Okay. So my first question is that, for example, here I have some missing values. Is that okay?
Yeah, actually I can show you how to handle them after you have asked all your questions.
Okay. So yeah, and my second question is that it's quite strange that I don't have any different value for kitchen other than 1 and no value. So is it okay, or maybe it has?
Yeah. Can you explain why there is some cases where is the value not given to you?
Well, I guess it's because in real life sometimes people are not telling those things. But it's
Yeah. So
is it possible that there is no kitchen in some places?
In Finland, no.
Okay.
Yeah. So the main reason is that it is not mentioned where the data was taken from. So it is just it can be writing mistake by the original data and so on, but because it's not mentioned also here.
okay. And you said you can tell me how to handle it. Is it with those missing?
Just take the screen out so I show it to you, to all of you at the same time.
Yes, okay.
I have to open my data, so that's why it takes some time. I share my screen. So as you see at this moment there is nothing, and I put some values here. And some of them are missing, and to make my life easier, just name this one as a case. And I know that for sure these values should be something, and even if I don't know, but I just want to have the number of actual observations be the same for all data. Because, for example, if you use this case as a nominal 1 and you use it for checking, like there is 37 female and 54 male in your data, and what would be the salaries. And for some workers, gender is not mentioned. These salaries would be excluded because they do not have this gender information, and for that reason you would like to know them. Of course, if it's the gender and you haven't done it by yourself, you don't have the papers of original information or anything else, you cannot change that one. But here, transform, you see there is the recode into same variables. And this is something I say that be very, very careful when using this one, because it's always treats the original values, and if you do the mistake in this case, it will affect everything. So I take the case here and I take old and new value. Here I can change the values to be whatever missing, but I take this system or user missing, and I say here, for example, that the value is 20, and then continue. And you see 20s are here at the empty places. If this one is given as a nominal one, why it didn't let me to do it? Let's see. Okay, it doesn't let me to do it here. But here I can say that if the value is 20, not known. So, for example, in all the graphs and so on, they would be shown as a one group, and for this we do not know it. But if it's only the dot there would be no information in these cases. Here we have cases from 1 to 20, and in sometimes if it's a numerical one, just think about, for example, the salaries. You do not want to have them separate ones, because if you want to know some more information about the persons earning from 20 to 30,000. So in these cases, you can use the recode into different variables. You take this one, you give a name for the new variable, the new case, and you can also write down the label here. So this would be the title used later in the graphs and in the tables. You have to push a change, otherwise you cannot save this one. So if this here is empty, OK is never coming to you. And then I can say that all the values from the lowest till 5 belongs to group 1. All the values between 6 and 10 belongs to group 2. And all the others, and of course, because this is something we don't know, we can say that they are at group 3, for example. Continue, and because there is the name, just OK. I have no idea why this output window is coming like this one here. You see there is the new variable, and it already tells you the groups. And once again, you can go to the label values here and say that from group 1 is salaries between 10,000 till 20,000. Not the case in this data, but you see the idea. Hopefully this helped you.
Yeah, but can I ask you, why do we where do we use this feature? Because in the data that you provided us before, there was no such cases when the nominal value has like really different numbers from 1 to 20. Only like I don't understand, like, where do we need this for our studies?
You need this one if you have this dot here. And if you just remember that if your data is very big, you have 500 or 300, you don't want to go it one by one. So you can use the first case to get these empty parts in form that where you just I show to you. So if I have this one and I take for example, let's take the graphs. And I put the case here. You see it has here only for cases 1, 2, 3, 6, 8 and 9. All of them is only once there. But no information about those empty ones. Although all the other information here is given. If you use that one and you give them some values and you do the same thing, it was not working, so I did forget something. So there should be all 20s. Now you have also the empty ones, so it would say to you if this is written not known, but there was no value given for 2 cases. What I did do here is that for somebody the annual salary can be, for example, 15,100. For somebody else, it's 15,225. And if they are like this, you have the 800 salaries, and some of them are so close to each other. You don't want to have them separately. I open one of my data.
I guess I asked not exactly the thing that I wanted to ask. So my real question is actually, will we use another data for our studies or
No, no,
no?
it's only
Okay.
this one.
But in the data that you gave, we don't have such cases when we need to say decrease the amount of cases to.
Okay, then
show-
you are lucky ones.
Okay. But it's just for common knowledge, right?
Yeah.
This feature. Okay.
If I remember correctly, there has been years when also the houses data has had these outliers. So it is not a rare thing at all. Anything else?
Yeah, I have a question. So we need to provide the introduction to our research, right?
Yeah.
As part of the technical statistical report.
Mhm.
And there we just describe what the kind of data we have, like flats, kitchens, all the stuff, right?
Yeah.
Okay.
So not as a bulleted list, just as a text. So if you just, for example, take any lecturing book and there is the introduction part or something else, so that kind of text explaining that, okay, I have these cities and so on, and what kind of variables, what did I study from them, and so on, but not bulleted lists, not tables yet.
Yeah, I think we'll do it like this because you put this mark about text, not tables, on Moodle.
Yeah.
So I was just curious about. Did I get it right that what you mean by research? So it's the data that we downloaded a couple of lectures ago. Okay.
So you just give a basic idea what you are going to do in the text, private text. It doesn't need to be a long one, so you don't need to write pages. In some cases, half of a page is already enough because you don't actually have all the tools yet to know what kind of things you can do.
Okay. Thank you.
No problem. Anything else?
Yeah, about that. For example, in my report, I said I wrote down like these data will be statistically analyzed. So should I specify what exactly will I do with this data, or for introduction, it's just
at this point, because you actually don't yet know what you can study, you don't need to mention it. So just give a basic information about your variables and so on. Maybe because it's about the flats or houses or something like that, you may have some kind of idea that, for example, if you would be buying a house, what kind of information would be valid to you. So it can give you the hints what you would like to study.
Okay, I see. Thank you.
I had something in my mind 1 minute or 2 minutes ago. Yes, about the reports. So the first report must be returned by on Sunday at the latest. The Moodle will close that place around the midnight, and I will not accept any reports sent after that. So when the Moodle closes that's it. So if you want to have your scores for this first report, please do it on time. And also for learning diary for the first part, I changed the date till 14th, 15th, 13th of February. I think it was February 7th first, but because this what we have been talking this week is part of that thing, then also the time changed to a little bit further away. So the second report for this week's things must be returned by, I just check the time, 12th of February.
So just sorry for interruption, but just to make it clear, so we only for this weekend we only have one report on the statistical part, and the impression part is gonna be in 2 weeks.
Yeah.
Okay.
Because
great.
this is part of it. Any of you, do you have a calendar? Is 12th? Okay, I have it. So it's Friday. So it's Friday, February 12th, the last date. All right. If you have nothing else, you can.
One small question. Yeah, I would like to clarify if I understand correct the word state. So in this case, it means like condition of the
Yes.
of the
Yeah.
apartment. So it's
Yeah.
like needs to be renovated or not needs to be renovated, something like that.
Something like that. So you can decide by yourself what kind of values you give for both. And if you just want to change the name of a variable so it's referring to something else, you can do it. So when I was getting the data, it was given as a condition, but it's your data. So for example, because you are from Russia, there may be some things which are more concerned in your case what people are checking when they are going to buy a new flat. Something special for you. So it's up to you if you want to change it. It doesn't matter.
Okay, I see. Thank you.
You are welcome. All right. Start doing your reports. I will be here for some time. If you have questions, problems, I will answer to you and try to get the reports from this part as far as possible. Because the times I gave you are the latest, not the first time, so you can return them earlier.